Fellow students, once again, my name is Andrew Keachman and my partner is Gregory McAdams. Today we'll be demoing our location tracking app in two videos. The first video will describe the features and the second will demo the tracking capability. So, start up the app. On startup, the user is greeted with a toast welcome to the app, and initially the world view is displayed, and once the GPS unit gets a fix, it will zoom into the user's location. And we add a marker displaying where the user is. And as the user moves, a marker will move based on the tracking algorithm, and a polyline will be displayed tracking the user's progress. It won't do anything now, but if I tap on the marker, it will clear the polyline for the current track path. In the top right corner, we have 4 overlay windows to display the bearing, step count, latitude, and longitude. These overlays will update as the app tracks the user's movement. We've also limited an options menu which allows the user to select from the 4 map types provided by Google based on his or her preference. So we have satellite, hybrid, terrain. We'll go back to our default one. The tracking algorithm that we used is based on taking GPS measurements every 2 minutes and then using a DR calculation every 5 seconds to track the user's location in between measurements. The DR calculation we used was based on Haversine equations. These equations can be used to calculate a new latitude and longitude given the original latitude and longitude, bearing, and distance traveled. For the bearing calculation, we used the accelerometer and magnetic field sensors along with the get rotation matrix method. Low-pass filters were used to smooth out this data. So you can see here, this is the bearing displayed. For tracking the distance, we initially explored using linear acceleration, but quickly determined that there was too much error in this approach. Instead, we tracked the number of steps taken in a 5-second window and then multiplied by an empirically determined meters per step to get the distance traveled. Using this information, a new lat-long point was found. Timing the app was controlled via handlers. The GPS timer re-enabled the GPS to take measurements, and the DR timer set a flag indicating when a new position should be calculated via the device sensors. We use another handler to update the map with a lat-long point from the GPS or the DR algorithm. So that message there, just in case that's a GPS update. You can see it moved just a little bit. Then you will see in a second or two. So that's the GPS, got a new fix. Takes a little bit longer inside. And then you see here, this is for those messages are for when the DR algorithm is being run. So if I tap on this line, as you can see, it clears the polyline. Well, that's pretty much it for our first video. We hope you enjoyed our feature description. Our second video will demo the app in action.